So some videos on conditional probability. We look at question 5 here. We're given the probability of A, the probability of B, and the probability of the intersection. So we can draw that quite easily. So let's have a look here. A and B. Is there anything on the outside? Normally. So we have A, we have B, we have my unit. So what are we given? The intersection, we can always start in the intersection, 1 over 4. A is a half. So that leaves another 1 over 4 in here. Half and a quarter is a half. B is a third. Well, a third is 4 over 12. So that would have to leave a quarter is 3 over 12. And B is a third. So we have 3 over 12 in the intersection, so that would leave 1 over 12 here. And if we add all them together in terms of 12, we have 1 over 4 twice. So that's 6 over 12 plus the 1 over 12 is 7 over 12 inside the circles, which would leave 5 over 12 on the outside. Okay, so let's have a look at some of these questions. A given B. So it's always the intersection of them. So the probability of A given B is the probability of A intersection B over the probability of the second one in this term, in this question, is B. So the probability of A given B is 1 over 4 divided by the probability of B, which is 1 over 3. So a quarter divided by a third is equal to 1 over 4 times 3 over 1, which is 3 over 4. So that's question 1. Question 2, B given A. So very similar, the probability of B given A, always write it out. B intersection A, which is the same as A intersection B, over the probability of the second, which in this question is A. So we have a quarter on top, divided the probability of A, which is a half. Just double check, a half. And a quarter divided by a half is 2 over 4, or 1 over 2. Question 3, A complement given B. So write it out exactly the same way, don't get confused. A complement given B is equal to the probability of A complement intersection B, where do they cross, divided by the probability of the second, which is the probability of B. So we look at the diagram, A complement intersection B. Where does everything outside of A cross over with B? Well, you just have to draw a few lines to see where does everything outside of A. Now this is outside of A, but it doesn't cross over with B. So we have A complement intersection B is that section there, which was 1 over 12. And if we divide by B, which was 1 over 3, we're going to get 3 over 12, or 1 over 4. There's a few of these, so if we go a bit, we can still see the diagram. So question 4, the probability of A given B complement is equal to the probability of A intersection B complement over the probability of the second one, B complement. So in that case, this is equal to A intersection B complement. Just change the color here. Where does A cross over with everything outside of B? You can see it's the opposite here. It's this quarter. So that's a quarter divided by the probability of everything outside of B. Well, this is inside of B, a third. So everything outside of B is 2/3. So we're going to end up with 3 over 8 here. 3 multiplied by 4 over 2, 3 over 8, 0.375 is the decimal. Okay, on to the next one. The probability of A union B. Probability of A union B, an easy one thrown in. Well, it's everything inside the circle, so we just look what's outside. 5 over 12, so 7 over 12 has to be inside. And then A given A union B, so the probability of A given A union B is equal to the probability of A intersection A union B over the probability of the second one, A union B. So what's this going to give us? So where does A cross over with A union B? Well, there's A union B. Where does A cross over with it? Just draw a circle around A. You can see it's everything inside A, so it's 1 over 2 divided by the union, which was 7 over 12. And this is going to give 12 over 14. That's question 5. Okay, question 6. In a school, what are we looking at? There's question 6. In a school, 150 girls and 100 boys. Well, it might be good to do a table here so we can see what's going on. 150 girls, so we're talking about boys and girls in a school and numbers. So there's 2 things going on. Put them down into a box. Probably the easiest thing to do. We'll call them boys and girls. And what is going on here? They either play hockey or they don't. 120 of the girls play hockey. So play hockey and no hockey. So 120 of the girls play hockey. And there's 150 of them, so 30 don't. There's our total. And the boys, 50 play hockey out of 100, so 50 don't. So there's 250 total here. There's 80 don't play hockey, and there's 170 play hockey. So just square off your table. And let's have a look at the questions that follow. So, a student is picked at random. Find the probability that the student is a girl given that the student plays hockey. So we write that out. The probability of a girl given they play hockey. So the probability of a girl given they play hockey. So we write that out. Probability of a girl where the girl intersects with playing hockey divided by the probability of playing hockey. So where does the girl intersect with playing hockey? Well, that's here. There's 120 out of 250 total. Now we don't need the over 250 total. We could say 120. That's where the girl intersects with playing hockey over the probability of hockey. The probability they play hockey is 170 over 250. So this could be 120 over 250 divided by 170 over 250 if you wanted to write out in long terms. So that's just going to give 12 over 17, which as a decimal is just over 70%, 0.7059. Okay, any other questions for 6? Plays hockey given student is a girl. So write that one out. Plays hockey given the student is a girl. Plays hockey. Plays hockey given the student is a girl. Plays hockey given the student is a girl. So the probability where plays hockey, not that looks like an A, plays hockey, where does that intersect with girl? And on the bottom, the probability of a girl. First one intersection, the second over the second. So the plays hockey, given that it's a girl, well that's 120, that's this 120 again. Or 120 over 250 is the probability that they play hockey. 120 over 250, I'll leave the 250 out, over the probability that it's a girl. Well, there's 150 girls out of 250, so 150, which is 12 over 15. And 12 over 15 is the same as, well, that's just 4 over 5, 80%, isn't it? 0.8, 80, yeah, 0.80. So that's just 4/5, 0.8. And is that just question 6? It's question 6 done. Okay, let's look at question 7. In a certain country, in a certain county, 70% of the population live in a townland, right? These are totals, and 30% live in rural area. And what are the options here? 50% of townlanders listen to the local radio or don't listen to the local radio. Okay, so that's what we have here. Local radio and a townland. So let's do a box up for that. So we take this column as my total. And I can put in over here where they live, and this is what they listen to. So they either live in town, population townland, and rural. So I take townland and rural. And the totals, 70% live in the town, which obviously leaves 30% in rural, and some of them listen to the radio. We'll call it don't listen to the radio. So what, 50% of townlanders listen to the local radio, 50% of townlanders. So 50% of townlanders listen to the local radio. So that's this box here, 50% of townlanders. Now there's 70% of the total. So 50% of 70% is obviously 35%, half it, 0.35. So that's, I need another line in here as well for my totals, coming down this way. So I have 0.35% of the overall population listening to the radio based on our townland. 20% of the rural dwellers listen to the local radio. 20% of 30%, 2 3s are 6, and we've 2 decimals, 1 2. So 6% of that 6, let's get rid of that 0 there, 0.06 goes there, so 0.41, 41% of the population listen to the radio, which means 59% of the population don't listen to the radio, and this has to be 0.35 to give us our 0.7, that was half and half, and this would have to be 0.24, and you can see these two do add up to my 59. Okay, let's have a look now at the question. So the probability the person is a townlander, so the probability that they're from town given they listen to the local radio. So this is my conditional probability. Where does town intersect with local radio over the probability of local radio? You can see here town intersects with local radio here, 0.35 over local radio, which is 0.41. And 41 is prime, so we can just leave our answer as this. If they're looking for it as a decimal, 0.85, a couple more there, 37. So that's what we have for the first 3 questions in conditional probability that I want you to look at.